I know we're only a day into this, 24 hours into this, but can I get some input? What would somebody do? Tony?
Just convert them because you
Get them into sine and cosine everything, okay? Remember, that's always a safe bet. So I have 1 over cosine squared plus 1 over sine squared equals sine squared over 1 over cosine squared. Okay? Now, here's where we run into a minor problem. And the minor problem has to do with the plus. Addition changes things, subtraction changes things. It doesn't work like multiplication and division do. I cannot flip and multiply this until I get it into one fraction. All right? So I would need to multiply the first fraction by sine squared over sine squared, and the second fraction by cosine squared over cosine squared. It's going to get messy, and I'm going to end up with a lot of fractions kind of going on. I'm going to give you my preference from this point. If you don't like it, don't do it. But I want to do the cross product thing. I like the cross product things because it cleans up those complicated fractions. I'm not saying you have to. If you want to, go ahead and find your common denominator and then flip and multiply from there. But I'm going to do it this way. And so that leaves me with 1 over cosine squared. That's my first cross product. And sine squared times that whole big catastrophe that caused the issue where I can't flip and multiply. Which means I'm just going to have to distribute that sine squared through. So I will have 1 over cosine squared equals sine squared over cosine squared plus 1. So that's how I cleaned this up from here. Anybody have a thought from there? And I'm not trying to like rush you or anything. Get your stuff written down, take a look at it, and talk to me about what you think. Yeah. Mm-hmm. What were you thinking?
Because sine squared over cosine squared is tan squared.
Indeed it is.
1,
Yeah, it is.
which would be secant.
It is, yeah. Mm-hmm. So this is tangent squared. And again, this is our way, this is where Courtney was going with this. This is tangent squared. This is secant squared. And tangent squared plus 1 actually equals secant squared. Okay? Again, there are so many different avenues to get here. And everybody's brain is a little bit different. And so go with something. We don't have to all be alike. Go with something. Jump in and kind of do it. All right? And we'll see different things from different people, different ideas, and it might give you ideas of your own. Any questions on that one? Should we go through what it would look like if we did find the common denominator? Or is that not important? No? Okay. Let's move on to our next one. Give me a start. Yeah.
Tangent squared x plus 1 equals secant squared.
It does indeed. So I know this over here is secant squared x. Awesome. Right side, check. How about the left? Should I go with the old standard or the old standby, put it into sine and cosine? Seem reasonable? Okay. That is 1 over cosine times 1 over sine all over cosine over sine. Can I flip and multiply now? Yes, because there's no plus in that denominator. It is a solid fraction. Flip and multiply. Let's do it to it. So this is times sine over cosine, and that is gone now. I flipped and multiplied. Notice I'm sort of taking some shortcuts, but I'm showing what I'm doing. So here, the signs cross out, leaving me with and very good. Yep. Ooh, that was 2 in a row where secant squared equals secant squared is the answer. Number 10. I love number 10. I don't know why I love it. I have no reason to, but it's a nice one. It goes quick. My mind is pointing at one thing in particular. My mind sees something that makes me smile.
The top is going to be 1.
Yeah, that right side top will be 1. So that is 1 over secant. And then the cotangent is cosine over sine. Oops, yeah, no, I'm good. I'm good. Never mind. Times sine over 1 equals. Good. This one went quick. Right? Can we see it? It's the future shining in our brain. What happens? Gone and gone. And two-steppers, those are the best. Okay. That is it for our notes. As for your homework, we did all of the identities in the homework packet, which leaves you with just the back side that we haven't touched. Actually, we did up through 52, right? So I would like you to do 53 to 62 evens or odds, I don't care. 53 to 62, evens or odds, whatever you feel like you want to do is up to you. And when I say I don't care, it's not in an insensitive way. It's in a free spirit way. Whatever makes you happiest. Okay. And on top of that, of course, there's always an and. Another set of practice problems. It says partner practice on it, but you can do however you want, by yourself or with somebody. And it's almost like what we did at the start of class, so we're wrapping it around again and doing a review of everything. You've got another identity on there, 2 more graphs. Extra, yeah. Yep, so evens or odds on the last of the homework. And then, this used to be a partner quiz, actually. If you want, I can still make it a partner quiz. I don't care. Totally, yeah, no, as long as they look alike. I know it seems, that was a lot of stuff, but again, especially with this stuff, the more you practice, the better you get. It's really good to keep thinking about those families and how they work together and what the graphs look like. all of that stuff important. So this is just a little more practice to add to it. Yes, more homework. Tomorrow is review and a graphing thing, so if today you're like, I didn't have time to finish everything, she piles on so much stuff, we'll have time tomorrow for sure, between the review and this. And then your test is Friday. And then we move on to our next chapter. They just get better and better as we go on. More exciting. Henry, you're scratching your head. They don't get better and better as we go on?
No.
Just scratching your head. Oh, I keep recording this, so the poor people at home have to listen to my not shutting up ever.